Electrochemistry deals with the formation of an electrical current by chemical means, and as you can see on the screen here, there is a battery. This is what your typical alkaline battery looks like. There is a cathode and an anode, and then an electrolyte which allows the current to pass through. So what we're going to deal with here in this particular section is chemically how a battery works, but we're going to start out with very basic things first. So let's take a look at some terminology in electrochemistry. Now, some of this is probably review. An oxidation reaction is a process in which an electron is lost from an element and the element attains a more positive charge or positive oxidation state. As you can see here, sodium, the solid, losing an electron, becoming sodium plus 1. Now the opposite reaction, which must also occur along with the oxidation, is a reduction reaction, and that is a process in which an element takes on an electron and therefore becomes more negatively charged. So usually what happens is an electron is lost in an oxidation and it's picked up in a reduction, and in the process those electrons traveling create a current. And as you can see here, the chlorine molecule picking up 2 electrons becomes 2 chloride ions. Now, this is just an old memory device that I used years ago for keeping oxidation and reduction straight. Leo the lion says grr, loss of electrons is an oxidation, gain of electrons is a reduction. And it's important to keep these two terms straight, because then that determines the flow of electrons within an electrochemical cell, which we are going to take a look at. Now, in addition, we also need to take a look at 2 other terms dealing with oxidation and reduction. The first term is oxidizing agent. Now, agent implies that that person is going out and doing something, and oxidizing is what that agent is doing. So an oxidizing agent is actually the substance that's reduced, because in getting reduced, that substance then oxidizes something else. So oxidizing agent is defined in terms of not what happens to the substance itself, but what it does to another substance in the reaction. And then the reducing agent, of course, is the substance that is oxidized, because as it is oxidized, it is therefore reducing another substance. So again, both of these terms are referring to reactants specifically, and they're referring to what the substances do themselves rather than what is done to them. So oxidizing agent actually does the oxidizing, reducing agent actually does the reducing. Now, the last set of terms that we need to take a look at would apply specifically to the electrochemical cell or to the battery, and that the first term here is the anode. Now, the anode is the electrode where oxidation occurs. So this is the electrode from which the electrons are lost. They then travel to the cathode, and the cathode is where the electrons are then picked up. This is where reduction occurs. And a good memory device for that is red cat, reduction at the cathode. Reduction at the cathode. Okay, so again, anode, oxidation occurs, electrons are lost, they travel to the cathode where they are picked up, and that is where reduction occurs. Now generally, we measure reduction in terms of voltage, and we do this as a relative value. This is a sample of a table of reduction potentials, and notice that hydrogen is boxed in. Hydrogen is the standard, so hydrogen is set at 0, and then all of these other reactions are measured against hydrogen and then assigned values. So if you chose another reaction as a standard, that particular substance would be 0, and then all of the other reactions would be measured against that standard, and so the values would change. The numbers would actually change, but their relative place in the list would not change. So fluorine typically is at the top of any reduction potential table, and even if we used a different reaction as a standard, fluorine would still be at the top. The value would just not necessarily be 2.87 volts. So again, this is done by making hydrogen the standard electrode. Now, this is how it's done basically. You put hydrogen in one half of an electrochemical cell, You put all of the other reactions individually in the other half of the cell, and then you measure the voltage. And by measuring the voltage, if hydrogen is 0, then the measured voltage must be the voltage of the other half of the electrochemical cell. So again, potentials are measured against hydrogen, and hydrogen is set as a 0 voltage. It is set as the standard.